Hello, good evening, everyone. Hope you can hear me as usual. Um, we said that we will work on this tutorial. What is this? Chemical calculation tutorial number 7. My tutorial is blue in color, but your cover page might be different. Differently, there might be different colors. Yeah. So, yeah. So this is starting from first question. Right? Shall we start? I hope you have worked it out. But let us right. This is a real important tutorial, right, on chemical calculations, and it covers all the redox, balancing equations, those things. Even though I haven't discussed the redox tutorial, it will cover certain things and it will remind you, right? Okay. Shall we begin? I hope all of you can hear me. Well, everyone? Okay? Right. Good. Let's start. Question number 1. The relative atomic mass of iron is this much. It's given, right? And the other thing that's there is permanganate reaction is given. Ferric to ferrous reaction is given. Both of these reactions are given in the reduction form. Construct full balance redox ionic equation for the permanganate ions. Manganate 7 means permanganate ion oxidizing the iron 2. Right. So what happens here? Permanganate. So permanganate undergoes reduction, whereas Fe plus 2 undergoes oxidation. Plus 3 and Mn plus 2. It's always better if you can write down the reaction in a single step. So how are we going to do that? Oxidation number plus 7. Oxidation number plus 2. So you see 5 electron exchange. 5 electrons. And here Fe plus 2 to Fe plus 3, you can see only 1 electron exchange. So what you do is you multiply this by 5. When you multiply this by 5, you have to multiply this by 5, also this by 5, right? Manganese, you don't have to multiply because you are multiplying it by 1. You don't have to write 1. So let us balance oxygen. 4 oxygen, 4 water. 4 times 2, you have to balance hydrogen. Hydrogen is 8H plus. If you do this right, the balance charges should be balanced automatically. What is the overall charge here? Plus 8, 5 times 2, 10, 18. 18 minus 1 is plus 17. On this side, what is the overall charge? 5 times 3 is 15. 15 plus 2, again plus 17. So I think it is balanced. As soon as the charges are balanced, you might be relieved. Okay, I got a balanced equation. That's a good thing. So that's all. 24.3 0.02 potassium permanganate. This one is 24.3 milliliters. And the concentration is 0.02 molar potassium permanganate reacted with 20 milliliters of iron 2. So this one is 20 milliliters. Iron 2, calculate the molarity of the solution. So what is the concentration, right? So whenever you do that, you write it like number of moles of Fe plus 2 to number of moles of permanganate, right? Is equal to permanganate is 5, Fe plus 2 is 5, permanganate is 1. So what is this? 20 milliliters concentration times 20 10 to the power minus 3 moles. Concentration times volume is equal to number of moles. Now that you are better at this, try to use minimum number of steps, moles per cubic decimeter, 0.02. What is the volume? Volume is 24.3 10 to the power minus 3 cubic decimeters. That is equal to 5:1. So things will cancel out. Moles and moles cancels out. Per cubic decimeters cancels out. 10 to the power minus 3, 10 to the power minus 3 cancels out. C is equal to 5 times 0.02 times 24.3 divide by 20. What is the unit? Moles per cubic decimeter. Because I use the unit here, you don't get a unit there. But actually, because we use that, so therefore, this is that 0.02 multiplied by 24.3 divided by 20. Your answer is 0.1215. Is that what you get? 0.1215 moles per cubic decimeter. Tell me what is your answer there. Right. Okay, good. Can we write the equation right? Can't we write the equation right away? I think you balance the equation. At the exam, they don't give you the equations. You need to know them. I just make sure to just to practice it. I gave you these equations. Right. Try to balance it. Balance it. Right. Okay. How do you recognize the endpoint of the titration? How do you recognize the endpoint of the titration? Because you know potassium permanganate act as a self-indicator, right? So this solution is, whenever you add potassium permanganate, it becomes colorless. And then when all the Fe plus 2 is over, next drop of potassium permanganate that you add gives you a permanent pink color. I have done these titrations practically also in the class, right? So what is the color change? By making a permanent pink color, a permanent pink color in the solution. Did you understand that? So colorless to permanent pink color. Yes, colorless to permanent pink color. Is it clear? Solution turns colorless. No. It turns into colorless solution. But at the end point, that colorless solution becomes permanent pink color. Did you understand that? Yeah. Pale green, none away. Where is the pale green? There's no pale green. Right? Fe plus 2, it is not, there's not much of a color that is there. So it's colorless to permanent pink color. Fe plus 2. Right? Right. Okay, right. Now let us look at the next one. Next one is calculate the percentage, part C. Calculate the percentage of, what is the cover page of the tutorial, right? It is not blue in color. I told you, I send you a message also in the morning. You should have done the tutorial and be ready with it, right? Colorless to permanent pink color, not purple. Purple is like you adding a very intense drop, one drop, and it gives you a pink color, right? Remember, I showed you that. Right. Okay. Calculate the next one, part C. Calculate the percentage of iron in a sample of steel wire if 1.51 grams of wire was dissolved in excess dilute sulfuric acid. So you have a metal. We don't know how much of this metal is there. So this is your metal. This is 1.51 grams. 1.51 grams is that, right? Dissolved in excess dilute sulfuric. So you add sulfuric to dissolve this. H2SO4 and it dissolves. So here you have Fe, iron. Iron reacts with sulfuric and it dissolves. And the solution was made up to 250 milliliters. Draw up a diagram. Whenever you draw these diagrams, you understand the question better. So 250 milliliters, standard graduated flask. Out of that, you take 25 milliliters. Out of that, you take 25 milliliters. Pipeted out conical flask needed 25.45 milliliters of 0.02 molar KMnO4 for complete oxidation, right? First thing that they ask is calculate the percentage of iron. Calculate, that is the question, calculate the percentage of iron in the sample of steel wire, right? So did you understand the question? Everyone, right? What gives the solution pink color? That is potassium permanganate, KMnO4. When you add one drop, it gives you this pink color. It's not purple. It is purple when you have it in a very intense color. You're adding one drop to a big solution. Like let us say this kind of a solution, you add one drop of purple color, it becomes pink color, right? Okay. Is it right? Okay. Now let us read the question. If you want to re-watch this, it is available. This explanation is available again in the website. You can watch it tomorrow, right? Again, right? So let us look at this one first, right? So now you have a metal rod. That metal rod react with sulfuric. So what will happen? Fe plus sulfuric, and it gives you ferrous sulfate. Ferrous sulfate is given together with hydrogen gas. So hydrogen gas evolves out. So you can see here, it gives you the +2 oxidation state. +2 is very, very pale green in color. But when you have a 250 milliliter solution, you might not see that color. Right? Like nearly colorless. Right? And then you oxidize this. Now, you know the oxidation reaction we have written earlier. Right? So I will copy that again. Right? Rather than balancing that again and wasting your time, I will just copy that again. And this is copied. Right? And then I will paste it here. So that is that reaction. Potassium permanganate reaction is that. So that doesn't change. Stoichiometry doesn't change, isn't it? Right? So stoichiometry doesn't change. This is the same reaction that will take place. Is it clear? Now what you do is, again, you know, in order for this to react, you need 25.45 milliliters of potassium permanganate, 0.02 potassium permanganate. So number of moles of Fe plus 2 to number of moles of permanganate. What is the stoichiometry, Buddha? Stoichiometry is Fe plus 2 is 5, potassium permanganate is 1. Right? So what is the number of moles of Fe plus 2? Number of moles of Fe plus 2 is 5 times number of moles of permanganate. What is that amount? 5 times number of moles of potassium permanganate means concentration times volume. Right? Concentration times volume. 0.02 times 25.45. 10 to the power minus 3 moles. But check whether you understood that part. Right? 5 times 0.02 times 25.45 10 to the power minus 3. So this is 2.545 10 to the power minus 3 moles. Is it clear? Is it clear? Did you understand that? This is the number of moles of Fe plus 2. But that is present in how many milliliters? 25 milliliters. No? You have taken only 25 milliliters for this titration. Your original sample is 250 milliliters. So let us calculate the number of moles in 250. So number of moles of Fe plus 2 in 250 milliliters. So how much is that? 10 times the value. 2.545 10 to the power minus 2 moles. So this is the number of moles of Fe plus 2. Right? Let it sink in your mind. Number of moles of Fe plus 2 is this much. Look at this one, Putha. Fe plus 2 to Fe is 1:1. Because if it is 1 mole, this is also 1 mole. So number of moles of Fe also is equal to that. So number of moles of Fe is equal to 2.545 10 to the power minus 2. Anybody who didn't understand up to that point? Everyone okay with that? Anybody who has a problem with that? That is the number of moles of Fe in that iron sample. So let us calculate the mass. mass of iron, number of moles times the molecular mass. මේවා කරන්න ඕනේ. Right? 2.545 10 to the power minus 2 moles multiplied by the molecular mass. What is the molecular mass? 55.9. Let us say 56 grams per moles. 55.9, 56, right? I rounded off. So what is that? Multiplied by 56. What is the answer? 1.4252. What do they ask? They ask you to calculate the percentage. Percentage of iron is equal to 1.4252 in how many grams? How many grams did we take? 1.51 grams. What is it in 100%? It's a mass percentage. තේරුණාද? 1.4252 divided by 1.51 multiplied by 100%, you get an answer 94.3%. Did you understand that? Right? Is it clear? 94.3. Right? Okay. Right. Everybody okay with that? Right. Good. Right. Everybody okay with that? Anybody who is having like kind of various troubles in that? Why do we divide by 1.51? Yeah, that is because if I scroll the page, you can see the sample is 1.51. 1.51 grams. Sample is 1.51 grams. And then actual Fe is 1.48, 4252. 1.4252, and then you divide. It's like this, if you have 25 marks, total is 25 marks, and you got 23 marks. What is the percentage? 23 divided by 25 multiplied by 100. That is the mass percentage, right? That is the mass percentage, right? Why is it not 8.52 grams? 8.52 is the second question, right? Did you understand that? It is a different question. Okay, right. So 94.3 Everybody okay with that? Right. Clear? If there are other specific questions, you can always ask. Right, 94.4. Right. Then I suggest a reason why the presence of dilute sulfuric acid is essential for the accurate titration, and why dilute hydrochloric acid, nitric acid are unsuitable to be used in the titration. I told you, when you have potassium permanganate titrations, KMnO4 titrations, you can't use HCl. Cannot use HCl. Why is that? Why? Because the chloride can react with potassium permanganate. Can you write the reaction? Can you write the reaction? Chloride can react with potassium permanganate, MnO4 minus. Right? So now what will happen is MnO4 minus turns into Mn plus 2. Chloride turns into chlorine gas. This is one way to produce chlorine in the laboratory. Right? Plus 5 to plus 2. Right? Plus 7 to plus 2, 5 electrons. Chloride minus to chlorine, 2 electrons. So multiply this by 5, this by 2. So this is 2, this is 2, this is 5. 5 times 2 is 10. How many H pluses? 16 H pluses. And you get how many water molecules? 8 water molecules. But check whether you understood that. So that reaction take place. Can't we take the mass of iron as 1.4 grams? Is 1.4252. Right. Okay. Right. Clear? So that is the reaction. So you get, it generates chlorine. Chloride turns into chlorine. Chloride turns into chlorine, right? Chloride turns into chlorine, and it gives out chlorine gas. So it will interfere with Fe+2, right? Meaning this is not only reacting with Fe+2, it is reacting with chloride also. So you can't use HCl. Can't use HCl, right? Cannot use HCl. Right? And then it says you can't use nitric acid also. Why can't you use nitric acid? Cannot use nitric acid because nitric acid can oxidize Fe+2 to Fe+3. Fe+2 turns into Fe+3. Then you will not be able to titrate this. If you have nitric, nitric is a very strong oxidizing agent. And if you have HNO3, HNO3 turns into nitrogen dioxide, NO2. If you want, you can balance the reaction. Patas gala balance karan, right? If you use nitric acid, it gives you a if you don't have Fe+2, it turns into Fe+3. Balance me. +1 to +2 to +3, 1 electron. This is +5, this is +4. It will reduce 1 electron, right? So now what will happen is you need to add one water molecule here, oxygen to balance, 3 here, this side is 3, 2 plus 1 is 3, this is 2H plus. There's already H plus is there, so you need to add 1 H plus here. So that reaction takes place. So concentrated nitric is a strong oxidizing acid. It will not stop at Fe+2, it goes to Fe+3, the highest oxidation state. So therefore, you can't use nitric acid to dissolve this. That is why you're using dilute sulfuric, not even concentrated sulfuric, dilute sulfuric. So that is why dilute sulfuric is used. H2SO4 is used, right? I have started discussing tutorial number 6 in the class, right? And then, we have discussed a lot of questions in tutorial number 6 also, and we will continue to do that. And this is tutorial number 7. And that is why, that theory we discussed there. And these questions you need to do, right? And it will cover redox and all the other ones as well here, right? And those other tutorials, I want you to attempt on your own. Most of the answers are given, right? Very important, right? Right. So then in the part D, now this is the thing. If you if there are certain parts that you don't understand, because I have 1 hour to discuss this, and this recording will be uploaded, and you want to maybe if you don't understand it, watch it very slowly. And if you still don't understand it, you can, when you come to the class, please ask, right? Otherwise, if I keep on explaining the same thing again and again, and it is very bad with the others, right? So that is also there, and we need to cover things up, right? So make sure to watch that. If there are really hard parts, you can look at this, right? Everybody understood that? So always remember, if you want, you can write it down as well. Concentrated, if you use HCl, chloride also will react with potassium permanganate. So then the titration is not accurate. If you use nitric acid, ferrous will turn into ferric, and you will not be able to do a titration at all. So that's why. Right. Let us look at the next question, part D. Read that question. Let us see whether we can figure it out. Right? No, 8.25. Now, this is a new question. New question. It's a different question. Right? Okay. 8.25 grams of iron 2 salt. So this contains Fe+2. How many grams? 8.25 grams. Iron 2 salt was dissolved in 250 milliliters of pure water. So now your solution is 250 milliliters. Pure water. 25 milliliter sample were pipetted out from the stock solution and titrated with 0.02 potassium permanganate. 0.02 molar potassium permanganate. So you are titrating it with potassium permanganate, right? The titration values observed were 23.95, 23.8, 23.85. Right. So there are three titration values that you have got. Right? Is it clear? What titration value should be used in the calculation and why? What is your answer? What is your thought on that? If you can come up with an answer to this, that will be good. What titration value can we use? What is the titration value can we use? Are we going to use the average of the three? Or are we going to use only the first two? Or are we going to discard the first? What do you think? Right? Are we going to only use the last one? Right. Yeah. You can see 23.95, 23.80, 23.85. You can see 8085, these are very close to each other. First reading, you have a little bit of a bigger value. Right? Did you understand that? 23.80, 23.85, they are very close to each other. But here, there is 3 drop difference. Here you have a drop difference of a 0.05. So anyway, first reading is usually, it is a rough reading. So don't use the first reading and then take the average of the other two readings. Make it average, right? So 23.95 milliliters is little off from the other values. Ignore and take the average of the other two and take the average of the other two. Did you understand that? Right? Did you understand that? So 23.80 plus 23.85 divided by 2. So we take that average. What is that average? 23.80 plus 23.85 divided by 2. Is 23.825. 23.825 milliliters. So you can take it as 82 or 83. Did you understand that value? Right, good. Right, we ignore the first iteration because it's a rough, right? Right, good. Right, average of the last two. Right. Okay, look at that. Calculate the moles of permanganate used in the titration. What is the number of moles? Second one. Number of moles of permanganate is equal concentration times volume. Concentration times volume. What is the concentration? 0.02. What is the volume? 23.825, 10 to the power minus 3 moles. So what is the value? 0.02 times 23.825, 10 to the power minus 3. What is the answer? 4.765, 10 to the power minus 4. 4.765, 10 to the power minus 4 moles. Did you understand that part? Did you understand that part? Right. Okay. Somebody asked me, is it wrong to take the first and the second average? That is wrong thing. It's like, kind of very big gap now. 95, 80. 80 and 85 are close together. So you take those two averages. 95 is far away and it is the first reading also. Usually when you do the first titration, it is like a kind of a rough reading. So that is wrong. Everybody okay? Right. Calculate the moles of this. Calculate the moles of ions in the titration. Third one. Now you all know we made this this equation earlier. Same titration. Nothing new. Right? Same titration. So you know the stoichiometry. Number of moles of Fe plus 2 to number of moles of permanganate. What is the stoichiometry, Puta? Fe plus 2 is 5, permanganate is 1. Right? So what is the number of moles of Fe plus 2? Number of moles of Fe plus 2 is 5 times the permanganate. Permanganate is 4.765 10 to the power minus 5. Minus 4 moles. 4.765 10 to the power minus 4 multiplied by 5. What is the answer that you get? 2.3825. 2.3825 10 to the power minus 3. Is it clear? Right? Everybody understand? Isn't it better to take 3 readings as we decrease the random error? And like, if you have 2 good readings and you have a very off reading, right? And you add it together, that entire thing becomes wrong, right? That is not how you do it, right? First reading is a rough reading and the other two are very close by. You take those two because usually the first reading is wrong. And at the same time, here the first reading is very off. So that gives you a kind of bigger error, right? Okay. Oh, is it clear? Right, good. Then calculate the moles of iron 2 got titrated. This is the number of moles of iron 2 got titrated. Calculate the mass of iron 2 titrated. What is the mass? Mass is equal number of moles times the molecular mass. So what is the number of moles? 2.3825 10 to the power minus 3 multiplied by, we say 56. This is the mass of iron got titrated, right? So what is that value? You get 2.3825 10 to the power minus 3 multiplied by 56. 0.133. 0.133. I will not go for all other decimal places, right? Calculate the total mass of the iron in the sample of iron 2. You can see here the titration was done for 25 milliliters. Look at this one, 25 milliliters. But the actual sample is 250 milliliters. So 10 times the value. So let us say, so the fifth one is this mass of iron in the sample 1.33 grams. I took this sample multiplied by 10. Right. Calculate the percentage of iron in the salt. What is the percentage of iron in the salt? Percentage of iron in the salt. Fe in the salt. Percentage of iron in the salt 1.33 divide by what is this? 8.25. 8.25 grams multiplied by 100%. 1.33 divided by 8.25 multiplied by 100%, it gives you 16.12. ඔය 94.2 කියලා කියන්නේ අර ඉස්සල්ල එකේ ගන්න උත්තරය. This one. This one, huh? That is that answer. Because it's a salt, right? Clear the. No problem. Like, even in physics, it is like that. Like, if you take a reading and if it is a rough reading, you have to always get rid of that, right? If you want to improve the accuracy, now let us say I can't, I don't know much, but then if you measure this using a normal ruler, it will not give you the proper accuracy. So in order to increase the accuracy, you use a vernier caliper. If you want to increase the accuracy even further, you use a micrometer screw gauge. So likewise, you can go for these other decimal places as well. So this one gives you a kind of a rough reading. This is rough reading, right? 23.95 is a rough reading. Is it clear, Putala? Did you understand that? Well, right? Okay, right. Okay. Others, those who had questions, right? Sure. Did you all get, anybody got this answer? Who got this answer? Anyone? Can you put a hand up if you got the answer? Right. Anyone? Right. So, okay, a lot of people got these answers. Very good. Well done. Right. Good. That's great. All right. Very good. Well done. Right. So, yeah. Now let us look at the next question. Right. Okay. Thank you. Thank you very much. That's good. Really good. Good. Well done. Right. Go to the second question now. Second question. This tutorial, I want you to genuinely do this tutorial. Like even more than the tutorial number 6. This set of questions, I want you to do them. Because these are organized in such a manner, you have these kind of simple questions. These are the simple questions compared to the exam question. And when you keep on doing them, you get the practice and you will be able to go and do the exam questions, which is given at the very last part, right? So don't hurry things up. Within like the next month, I want you to gradually finish them. Like, try maybe 1 or 2 questions every day. That will help you to do it well and remember, right? Given the 2 half reactions, you see tetrathionate is given, S4O6, 2 minus, plus 2 electrons, no. Yeah, plus 2 electrons giving thiosulfate. S2O3, 2 minus. That is for a iodometric titration. I want you to look at those iodometric titrations, potassium dichromate based titrations, all of them again and again, right? So that you get the maximum benefit of this discussion. Then මෙතන ඔයාලට titration ඉගෙන ගන්න බෑ. We have learned these titrations for a long time. I never rushed them. මම හිතන විදිහට, right? I took a lot of time. Every titration I gave at least 2 or 3 days. Construct the full ionic redox equation for the reaction of thiosulfate and iodine. Right. So iodine plus thiosulfate, 2S2O3, 2 minus. Okay, this is 2. 2 minus, giving you 2I minus plus S4O6, 2 minus. And that is the redox titration. Did you get that? Everybody? Is it clear? Right, good. Then it says, what mass of iodine react with 23.5 0.012 thiosulfate solution? Right. So let us look at this one. Number of moles of iodine. You can't directly calculate the mass. Number of moles of thiosulfate is equal to, iodine is 1, thiosulfate is equal to 2. So number of moles of iodine is equal to number of moles of thiosulfate is 2O3, 2 minus divide by 2. What is that? Thiosulfate 0.012. But under the concentration they have given 0.012 times 23.5 10 to the power minus 3. Divide by 2. Moles. Right? You need a current. So what you have is 0.012 times 23.5 10 to the power minus 3 divide by 2. What is the answer? What is the answer? Write it for me. 1.41 10 to the power minus 4 moles. This is the number of moles that you get. What do they ask? They ask you to calculate the mass of iodine. Mass of iodine, what is that? 1.41 10 to the power minus 4 multiplied by molecular mass of iodine is 127, right? 10 to the power, 127 multiplied by 2 grams. So this is what you get. So multiplied by 127 times 2. What is the answer? Right? Give me an answer there very quickly. Right. Very quickly. What is the answer, Utala? What did you get? 0.0358. 0.0358 grams. Everybody understood that? Right? What mass of iodine is there? Did you get that? 0.0358, 35.8 milligrams. Very good. Well done. Hurry. Then they ask you, part C, meter, right? 25 milliliters of a solution of iodine in potassium iodide. You know iodine, I2. I2 doesn't dissolve in water. Why? Because it forms dipole-induced dipole. That's why you have this I minus iodide ions. Right? Can you tell me what are the interactions that you would get? Then it comes from bonding. Bonding is a very important chapter. But it's really important to understand those. Right? Very important to understand that. What is the interaction? What is the interaction that is there? This is delta plus, this is delta minus. What is that? What is that interaction? Very quickly. Quickly tell me. What is that interaction? Iron-induced dipole. This is a iron. This is a induced dipole. Induced dipole. Iron-induced dipole. Then London dispersion neve. Iron-induced dipole. Iron-induced dipole. Did you understand that? Iron-induced dipole. Right? So iron-induced dipole interaction is what you have. Everybody understood that? Very good. Well done. Right. So that is why it says 25 milliliters iodine in potassium iodide. Because iodine you can't dissolve. So it gives you this gives you a reddish brown color in the solution. Reddish brown color. Reddish brown color to the solution. Required 26.5 milliliters. Make it 26.5 milliliters of 0.095 molar sodium thiosulfate. Titrate iodine. What is the molarity of the iodine solution and the mass of iodine per cubic decimeter? So molarity means concentration. If you look at the reaction is the same. So we will take this reaction. This is our reaction. This reaction is the same. This reaction is the same. You have this reaction here, right? Right, okay. So what do they ask? What is the molarity of the iodine solution? So you say number of moles of iodine to number of moles of sodium thiosulfate is 2O3 2 minus. Iodine is 1, sodium thiosulfate is 2. So what is the number of moles of iodine? Number of moles of thiosulfate divided by 2. What is the number of moles of thiosulfate? Concentration is 0.095. What is the volume? 26.5, 10 to the power minus 3. Moles divided by 2. That's your answer. 0.095 times 26.5, 10 to the power minus 3. And the entire thing is divided by 2. So you get 1.258. I will take it as 1.258 to 6, 10 to the power minus 3. So this is the number of moles, right? What do they ask? What is the molarity of the iodine solution? So what is the concentration? Concentration is equal to number of moles divided by volume. 1.26 10 to the power minus 3 moles divided by volume is, what is the volume? Volume is 25. 25 10 to the power minus 3 cubic decimeters. 1.26 divided by 25. Here the 0.050504 moles per cubic decimeter. Or did you understand that? Did you get that answer? Did you get that answer? Those who got that answer, 0.0504. And VMI. Good. Very good. And good. Well done. VMI. Well done. Right? And the mass of iodine per cubic decimeter. So this is mass of iodine. So 0.0504 multiplied by the molecular mass of iodine, 127 multiplied by 2 grams per cubic decimeter. They don't say milligrams. 127 times 2. So 12.8 kilodalton. 12.8. 12.8 grams per cubic decimeter. Right? What is the molarity? Did you all get that answer? How does it work? Right. I wrote 0.05. It's okay. It's okay. Don't worry. Right? 0.05. 12.8. Good. Very good. Well done. Shah. Niyamai. Anna. That is where you try to actually find yourself in chemistry. Right? Okay. So put the answer say to me 12.8 should be there. I don't know. Let's see. Right. Are you ready to do the next question? Question number 3. Right. Let's see whether we can do the question number 3. Right. 2.83 of a sample of hematite iron ore. Hematite iron ore. Hematite. Now we don't know what is hematite. That is why they have given this Fe2O3. The sample is 2.83 grams. Was dissolved in a concentrated hydrochloric acid solution and diluted to 250 milliliters. This is dissolved and concentrated Fe2O3. You add HCl. It gives you, this is +3 oxidation state. Now look at this, you can see this +3. So got no change in the oxidation state. It gives you FeCl3 plus H2O. That is how it dissolves. Balance karan 2 FeCl3. 2 times 3, 6H plus. 6H plus means you have to have 3 hydrogen, oxygen is balanced. And it gives you FeCl3 and dissolves. Right? FeCl3 and dissolves out. Right? Is it clear? Did you understand that? Okay, right. So this is, then what will happen is this 25 milliliters of this solution was reduced. The Meakin gun not 25 milliliters. Right? This total volume is 250 milliliters. This is 250 milliliters. Out of that, you take 25 milliliters. Right? Reduce with tin 2 chloride. So you are reducing this. You understand what is reduced? Reduce means the oxidation number will be dropped using what? Tin SN plus 4. SN oxidized tin 2 chloride, SN plus 2. Sn plus 2 is oxidized to Sn plus 4. Right? All the details are given to you. Gradually read it and understand. That's a skill that you need. Right? So what will happen is I will erase this chloride thing and I'll write Fe plus 3. These are all ions. So Fe plus 3 turns into Fe plus 2. You can see plus 3 to plus 2, 1 electron. Plus 2 to plus 4 is 2 electrons. So multiply this by 2. 2 times 3, 6 plus 2, 8. 4 plus 4, 8. And now that is the reaction taking place. Everybody understood that? This solution of iron 2, then make a Fe plus 2 is there. Now you get Fe plus 2. That Fe plus 2 is this solution of iron 2 present requires 26.4 milliliters of 0.2 molar potassium permanganate. So you potassium dichromate, K2Cr2O7. You use potassium dichromate to oxidize this. The volume that you need is, concentration is 0.02 molar. Volume you need is 26.4 milliliters. Did you understand that question? Tell me first. Right? Did you understand did you understand that? Is it clear? Everybody understood that question. Is it clear? Right. Right. Explain the process again. You have a hematite, Fe2O3, right? If you Fe add HCl, it dissolves. Without changing the oxidation state, it dissolves. Dissolves means here there's no change in the oxidation state. It's plus 3 no maximum. So here no change in the oxidation state, plus 3. Now you all know that plus 3 you can't titrate. So you have to reduce it, plus 2. So what you do is you add tin. It is mentioned in the text, it is mentioned. When you add Sn plus 2, Fe plus 3 is reduced to Fe plus 2, Sn plus 2 goes to Sn plus 4. So it is reduced. It turns into Fe plus 2. Now what you do is you titrate this Fe plus 2 using dichromate. You remember dichromate titrations, right? Did you understand that? Those who said I didn't understand, is it clear? Tell me what part you didn't understand. Right? So Fe plus 3 is oxidized. It's like, it's dissolved first. And it is reduced by adding tin. So it goes to a low oxidation state. Now what you do is you add acidic potassium dichromate and titrate. That's all. Right. Okay. So I hope you got it. Now you let us write down the reaction. Fe plus 2 plus Cr2O7 2 minus. Cr2O7 2 minus turns into Cr plus 3. Fe plus 2 turns into ferric again. Right? Now the one that is having a low oxidation state undergoes oxidation. So we add dichromate to titrate. Yes, we are titrating it using dichromate. So Fe plus 2 to Fe plus 3, 1 electron. Dichromate is plus 6 to plus 3, 3 electrons. There are 2 atoms. So 6 electrons. Multiply this by 6. This is 6. This is 6. To balance the mass, you have to multiply this by 2. Balance oxygen, you have to add 7 water. 7 times 2, 14 H plus. Now it balances hydrogen. Did you understand how to balance this? Right. Okay. The reduction of iron 3 ions by tin 2. That is what happens here. This is the part 1. Iron 3 is reduced to iron 2. The oxidation of iron 2 by the dichromate. Fe plus 2 oxidized to Fe plus 3. That is the reaction. Everybody okay with that? Right. Calculate the percentage of iron 3 in the oxide in the OR. Right. We'll do that. We will stop it. Right. So let us look at this one. Number of moles of Fe plus 2 to number of moles of dichromate. Cr2O7 2 minus. Fe plus 2 is 6, dichromate is 1. So number of moles of Fe plus 2 is equal to 6 times dichromate. Look at the dichromate. Look at that. That is your dichromate amount. 0.02 times 26.4 10 to the power minus 3 moles. What is that amount? 6 times 0.02 times 26.4 10 to the power minus 3. 3.168. 3.168 10 to the power minus 3 moles. Now, how much did we titrate? We titrate only 25 milliliters. We titrate only 25 milliliters. Actual sample is 250 milliliters. So let us look at that. So number of moles of Fe plus 2 in 250 milliliters. How much is that? 3.168 10 to the power minus 2 moles. That is Fe plus 2. Right? The water pain on it. Right? That is the number of moles of Fe plus 2. Right? If you have Fe plus 2, you have the same number of moles of Fe plus 3. 2 is to 2. Number of moles of Fe plus 2 and Fe plus 3 should be the same. So that is equal to number of moles of Fe plus 3 is equal to 3.168 10 to the power minus 2 moles. Right. If you know the number of moles of Fe plus 3, look at this. Pay attention. Right. If you know the number of moles of Fe plus 3, Fe2O3 is 1. Whenever you have 1 mole of Fe2O3, you get 2 moles of Fe plus 3. So what is the number of moles of Fe2O3? Number of moles of Fe2O3 is half the value. 3.168 10 to the power minus 2 moles divided by 2. Stoichiometry. 3.168 10 to the power minus 2 divided by 2 is equal to 0.01584. 0.01584 moles. That is the number of moles of Fe2O3. What is the mass of Fe2O3? Mass of Fe2O3 is equal to 0.01584 moles multiplied by what is the molecular mass of Fe2O3? Molecular mass of Fe2O3. Fe56. 112. 112 plus 16 times 3, 48. 160 grams. This and this cancels out and you get multiplied by 160. 2.53. 5344 grams. So what do they say? They ask you to calculate the percentage. What is the percentage mass? 2.5344 grams divided by the mass of the hematite sample is 2.83. multiplied by 100%. Grams and grams cancels out. 2.53 divided by 2.83. 89.5 kilo. Is it clear? Did you understand that part? It's like a kind of a lengthy calculation. And it says, suggest why potassium permanganate isn't used for the titration. Why can't you use potassium permanganate? Can somebody tell me why that is? Why can't you use potassium permanganate for this titration? Why do you have to use potassium dichromate? I can see it's not a primary standard. I think you can take it as a secondary standard. Now, people do potassium permanganate titration, don't people do potassium permanganate titration? Not because it is not a primary standard. True that it is not a primary standard, but the concentration can be measured, calculated. Why? Because you dissolve this in HCl. Okay? You dissolve this in HCl. If you use HCl, what will happen? Those chloride ions will start reacting. So it is not only Fe plus 3, but the chloride also will start reacting. Did you understand that? So why? Because chloride ions are present. And it begins to react. It begins to react. Okay, right. So next week, we'll look at question number 4, 5, 6, 7, 8. Try those questions, right? Last minute questions. Right. Work out. I'm discussing these questions now. I can't discuss several tutorials at the same time. I'm discussing this tutorial now, right? So it is up to you to do the other questions. Try them. Okay. Yeah. You could, you have to do it as much as possible and become familiar. Make a familiar in the morning. You can't avoid that and go to a next thing. You get stuck after some time. Okay. So please do it now. Karan. And then when you come to the class also, if you ask me, I can do those things again. Monari questions we can discuss, right? Okay. So I'll leave you to it. Please do this, Right. Okay. Right. Thank you. Good night. Children.